The J-pole antenna is a popular, practical and highly efficient omnidirectional antenna. At its core, it is an unfed half-wave dipole that uses a clever impedance matching trick to connect to standard coaxial cable. Here is a breakdown of how it works and how it radiates your signal. The fundamental challenge of an unfed half-wave antenna is that the end of a half-wave wire has a very high impedance, often between 2000 to 3000 ohms. Standard radio equipment and coaxial cables operate at a low impedance of 50 ohms. If you connect 50 ohm coax directly to a 3000 ohm antenna, most of your RF energy will reflect back to the radio, resulting in a terrible standing wave ratio or SWR. The J-pole solves this by adding a quarter wave shorted matching stub, the hook of the J. Here is how the sections function together. The radiator, top section. This is a half wavelength, that is half lambda, piece of wire or tubing. It is the part of the antenna that actually radiates the RF energy into the air. The matching stub, bottom section. This is a quarter wavelength lambda by 4 transmission line that is shorted at the very bottom. At the shorted bottom, the voltage is 0 and the current is maximized, meaning the impedance is nearly 0 ohms. At the top of this stub, where it connects to the radiator, the voltage is high and current is low, meaning the impedance is thousands of ohms. The feed point. Because the impedance of the matching stub smoothly rises from 0 ohms at the bottom to thousands of ohms at the top, there is a specific sweet spot slightly up from the shorted base where the impedance is exactly 50 ohms. You attach your coaxial feed line, send a conductor to the main element, shield to the shorter stub, exactly at this point to achieve a perfect 1:1 match. This location is identified by trial and error. The radiation pattern. The J-pole is an excellent choice for local line of sight communications like VHF-UHF operations because of how it shapes the RF energy. Azimuth plane, horizontal. Looking down at the antenna from above, the radiation pattern is omnidirectional. It radiates nearly equally in a 360-degree circle. Note that the presence of the parallel matching stub can cause a slight skew or directional pull, usually 1 to 2 decibels, away from a perfect circle, but for practical purposes, it performs identically in all directions. Elevation plane, vertical. Looking at the antenna from the side, the J-pole has a low angle of radiation. Instead of wasting energy shooting straight up into the sky, it compresses the RF energy downward towards the horizon, resembling a squashed donut. This low takeoff angle maximizes your signal's reach across the ground to distant repeaters or other stations. People have contacted through the repeater, that is the cross-band repeater on the International Space Station using J-pole antennas. Summary of key dimensions. To visualize the physical structure for a specific frequency, the J-pole is roughly 3/4 of a wavelength tall in total. Total height lambda by 2 radiator plus lambda by 4 matching section. Stub length lambda by 4. Gap spacing. The parallel elements are typically spaced about 2% to 3% of a wavelength apart.